Hello students, this is the video on topic tests for quant that we have available at Bodhee Prep for you. The tests are so designed that they'll help you evaluate whether a concept that you think you've prepared for. So if there is a topic for which you've done concepts, you take this test and you get to know whether you're able to apply those concepts in an exam, in a test or not. Once you take the test, there is a video with every test which has the solutions and a brief analysis of what could have been a good attempt in terms of questions, in terms of time, and there are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make the most of these tests. This video specifically is on topic logarithm. And this is the fourth test on the topic that we are discussing in this video. Overall, I think moderate level of difficulty for the test. 6 questions net correct in a test like this should give you a 95 plus percentile. And the attempt time for a test like this, again, the idea is to go through the 10 questions and find out your 6 best questions is what I'm saying. It should take about 23 odd minutes to get that done. If you look at the questions, the first question says log of 7 raised to power x square minus 3x plus 2 raised to power 5 to the base of x square plus 4x minus 4 is equal to log of 529 to the base x to the power x square minus 3x plus 2 to the base of 23 5 by 2. So first let us deal with the right hand side. This can be written as log of 529 is 23 square. So 23 square into x square minus 3x plus 2 to the base of 23 to the power 2 by 5. 2 by 5 can come out as 5 by 2 the power of the base. And this comes out as it is 2 into x square minus 3x plus 2. Log of 23 to the base 23. Log of 23 to the base 23 becomes 1. And therefore, on the right hand side, we have 5 times x square minus 3x plus 2. What we can do is on the right hand side, on the left hand side, we can take the 5 in front and write as 5 times log of 7 raised to power x square minus 3x plus 2 to the base x square plus 4x minus 4. So this also gets cancelled out. And therefore, from here we can say x square base to the power should be equal to the value for which we have taken log. X square plus 4x plus 4 raised to the power this power x square minus 3x plus 2 should be equal to the value of the term for which we're taking the log. So x square minus 3x plus 2. Either now the base will be same, which means x square plus 4x plus 4 will be equal to 7, which means x square plus 4x minus 3 is 0. B square minus 4 is 16 plus 12 root 18. X is an integer. From here we will not get an integral value. The second possibility is that the power is 0. A raised to power 0 will be equal to b raised to power 0 irrespective of a and b. And therefore x square minus 3x plus 2 is equal to 0, which means x minus 2 into x minus 1 is equal to 0. So x is equal to 2 or x is equal to 1. If we put x is equal to 1 here, 1 plus 4 minus 4, we get the base as 1. The base cannot be 1. And therefore, this is not an answer. X is an integer. What is the value of x? The only integral value that we have left is 2. That becomes my answer. I say moderate to difficult level of question because there are 2-3 changes that will have to be made for us to reach the quadratic. 2.5 minutes should be good enough to answer this question. Find the value of log of 16 root 2 to the base of 4th root of 2 plus log of 32 root 32 to the base cube root of 2. So just let us reduce it to 2 power of 2's first. Log of 16 raised to power 2 will be 2 raised to power 4 into 2 raised to power 1 by 2 to the base 2 raised to power 1 by 4 plus log of 32 is 2 raised to power 5 into 32 is 2 raised to power 5 by 2 32 is 2 raised to power 5, and then root is 1 by 2 to the base 2 raised to power 1 by 3. So this can be written as 1 by 4 comes out as 4. 4 plus 1 by 2 will be the power here into log 2 in 2 to the base 2 plus 1 by 3. 3 comes out from the power of the base into 5 plus 5 by 2 into log 2 to the base 2. This becomes 4 to the 8, 9. 36 by 2 log 2 to the base 2 is 1 plus 5 2s are 10, 15. 45 by 2 log 2 to the base 2 is 1. This becomes 81 by 2, which is nothing but 40.5, option A. I think this is an easy question in the sense that we just have to express each number as a power of 2, and then we're just working mostly in dices. Let x and y be positive real numbers such that log of x plus y to the base 5 plus log of x minus 2 to the base 5 is equal to 3. Log of y to the base 2 minus log of x to the base 2 is equal to 1 minus log of 3 to the base 2. So let us take the first equation first. Log of a plus log of b is equal to log of a into b. So we can write this as log of x plus y into x minus y to the base 5 is equal to 3. This means 5 cube. X plus y into x minus y, which is x square minus y square is equal to 5 cube, which means x square minus y square is equal to 125. The second equation says log of y to the base 2 minus log of x to the base 2 is equal to 1 plus log of 3 to the base 1 minus. If I write 1 in terms of 2 as well, we will be able to remove the log. So log of a minus log of b is log of a by b to the base 2. Here 1 can be written as log of 2 to the base 2 minus log of 3 to the base 2. Again, log of a minus log of b will be log of a by b to the base 2, and therefore y by x is equal to 2 by 3. We have to find the value of xy. From here we can write y as 2k, x as 3k, 2k, 3k, and therefore here we'll get 9k square minus 4k square is equal to 125, which means 5k square is equal to 125, which means k is equal to k square is equal to k is equal to 5. And therefore y will be 5 2s are 10, x will be 5 3s are 15. And therefore x into y will be nothing but 15 into 10, 150. Option D becomes my answer. Again, there are two equations in logs here which have to be solved. So I'm saying moderate level of difficulty question, but since the numbers are not too large, maybe 2 minutes should be good enough to answer the question. Log of 8x plus 5 to the base 36 is less than log of x to the base 6 plus log of 2 to the base 6 if and only if x is greater than. So log of 8x plus 5 to the base 36 is less than log of a plus log of b is log of a into b. From here we can say 8x 36, sorry. So 36 can be written as log of 8x plus 5. 36 is 6 square is less than log of 2x to the base 6. The power of the base goes out as 1 by 2. So this becomes something like this. We can cross multiply the 2. Log of 8x plus 5 to the base 6 is less than 2 times log of 2x to the base 6, which means log of 8x plus 5 to the base 6 is less than log of 4x square, 2x whole square, 4x square to the base 6, and therefore 8x plus 5 is less than 4x square because the base is greater than 1. So from here we can write 4x square minus 8x minus 5 is greater than 0. Two numbers which have a product of 20, difference of 8 can be 10. 4x square plus 2x minus 10x minus 5 is greater than 0. 2x into x plus 2 minus 5 into x plus 2, 2x plus 1, not x plus 2. 2x into x plus 1 minus 5 into 2x plus 1, 2x plus 1 is greater than 0, and therefore 2x minus 5 into 2x plus 1 is greater than 0. So the critical points become 2x minus 5 is equal to 0, 5 by 2, 2x plus 1 is equal to 0, so minus 1 by 2. Positive, negative, positive. So x could be either greater than 5 by 2 or less than minus 1 by 2. But we'll not have x negative because this value we are calculating, we cannot take the log of a negative value. So the negative part is eliminated, and therefore the only possibility is x greater than 5 by 2 becomes my solution, option C. One step of change is to be made, and therefore I'm saying easy question. Probably within a minute and a half, this or 2 minutes, this could be attempted. If log of x minus 1 to the base 0.4 is less than log of x minus 1 to the base 0.6. Here the base is less than 1. Therefore, the sign, we have to be careful with the sign. X lies in the interval. Now, this can be written as log of x minus 1 to the base log of 0.4 is less than log of x minus 1 to the base log of 0.16. 0.16 is nothing but 0.4 whole squared, 0.4 squared. And therefore log of x minus 1 upon log of 0.4 is less than, this becomes log of x minus 1 upon 2 log of 0.4, 0.4 square, 2 comes in the front. And therefore, cross multiply 2 here, 2 log of x minus 1 upon log of 0.4 is less than log of x minus 1 upon log of 0.4. Taking it on the left hand side, we get 2 log of x minus 1 minus log of x minus 1 upon log of 0.4. This is less than 0. 2 minus 1 is 1, so this gives us log of x minus 1 upon log of 0.4 is less than 0. Now, log of 0.4 to the base 10 will be a negative value. 10 raised to power minus 1 is 0.1. So 0.4 also we need a negative value, and therefore if you cross multiply, the sign has to be inverted. And therefore log of x minus 1 has to be greater than 0, which means x minus 1 has to be a value greater than 1. If the log of a number is greater than 0, that means the value has to be greater than 1. 10 raised to power 0 is 1. So x minus 1 is greater than 1, and therefore x is greater than 2. From the options, option A becomes the answer. Again, in terms of level of difficulty, I'd say definitely the thing that is to be remembered is since we are dealing with a base which is a decimal value between 0 and 1, be careful of the sign. Otherwise, I think straightforward question, about 2 to 2.5 minutes to solve. X is a positive quantity such that 2 raised to power x is equal to 3 raised to power log 2 to the base 5. Then x is equal to. Now we know that a raised to power log b can be written as b raised to power log a. You can interchange the value. Therefore, 2 raised to power x can be written as interchange 2 and 3. 2 raised to power log 3 to the base 5. Which means since the base is same, x is equal to log 3 to the base 5. Log 3 to the base 5. But since that is not one of the options that is given to us, we try to bring it down to the options. For example, if we look at this base 5, from the options looking at base 5, What we do here is we add 1 and subtract 1. The answer does not change. I write this as 1 plus log 3 to the base 5. 1 can be written as log 5 to the base 5. Log a minus log b is nothing but 1 plus log of a by b. This matches option C and that becomes my answer. Again, the question is easy, but the options can be a little off-putting. Therefore, moderate question in about 2 minutes. N is 5 times log of x to the base 2 square minus 5 times log of x to the base 2 is minus 8. X raised to power n is 16. Find the value of x. Suppose log of x to the base 2 is equal to y. We can write n as 5y square minus 5y minus 8. Also, here if we take log, we'll write n log x to the base 2 will be equal to log 16 to the base 2. And therefore, n is 5y square minus 5y minus 8 into x. X is log of x to the base 2, which is y itself, is equal to 16. Log of 16 to the base 2, which will be 4, because 2 raised to power 4 is 16. And therefore, 5y cube minus 5y square minus 8y plus 4 is equal to 0. X, find the value of x is what we have to do. This should be a minus 4 here. Now we have to find a real solution for y. Y, if we put values of y is 0, minus 1, 5, minus 5, minus 5, minus 10, plus 8 will not happen. 1, 5 minus 5, minus 12, 2, 2 cube 8 minus 5. 8 minus 5 will be 40 minus 20, 60. 2 satisfies this equation. Therefore, one of the roots for this equation will be y minus 2. The remaining part will be 5y square. So 5y cube minus 10y square. Minus 10y square plus 5y will give us 5y square minus 10y minus 8y. So we need plus 2y. Plus 2. This is 0. From here we can see b square minus 4ac 25 minus 40 will be imaginary, so there will be no real roots. The only possibility of a real value of y is when y minus 2 is 0, so y is equal to 2, which means log of x to the base 2 is equal to 2, which means x is equal to 2 square, which is 4. And that becomes my answer. For me, it is a difficult question because we get a cubic equation which we have to solve eventually. And there are two replacements that we are making. Luckily, I was able to get a root which was 2, but this could take time, which will lead to an exponential increase in my attempt time. What is the number of digits? What is the number of digits in 5 raised to power 20? 5 raised to power 20. Log 10, let 10 raised to power x be 5 raised to power 20. Taking log to the base 10, we get log of 10 raised to power x is equal to log of 20 raised to power 5, 5 raised to power 20, which means x log 10 to the base 10 is equal to 20 log 5 to the base 10, which means x is equal to 20 log 5 to the base 10. The problem is value of log of 5 is not given, log of 2 value is given to us. Now, if we write log of 10 to the base 10 as 1, and from here we will write 10 as 5 into 2, we can write log of 5 to the base 10 plus log of 2 to the base 10 is equal to 1, which means log of 5 to the base 10 will be 1 minus log of 2 to the base 10, which is 1 minus 0.3010, which means log of 5 to the base 10 would be 0.690. 301,001. This value we can substitute here. So x becomes 20 into 0.699, which becomes 2 into 6.99, which becomes 8, carry forward 1, 8, 9, 1, 13.98. And therefore 10 raised to power 13.98 is equal to 5 raised to power 20. 10 raised to power 13 has 14 digits. 10 raised to power 14 has 15 digits. This is where 15 digits starts. Therefore, 10 raised to power 13.98 will also have 14 digits. The least integer greater than equal to the value that we are getting, option C becomes my answer. Again, this is a standard process. So I'm saying easy question because we have to find the value of log 5. Therefore, probably 2 minutes to solve. Find the number of consecutive zeros immediately after the decimal in 1 raised to power 1 by 20 raised to power 37. Let 10 raised to power x is equal to 1 by 20 raised to power 37. Therefore, 10 raised to power x is equal to 20 raised to power minus 37. Taking log on both sides, x log 10 to the base 10 is equal to minus 37 into log 20 to the base 10. 20 becomes, let us calculate log 20 to the base 10 separately. This will be log of 4 into 5, which is log of 4 plus log of 5. Or rather, we can write this 10 as 2, which is better. Unnecessarily, we'll have to calculate 5. We can write 20 as log of 10 into 2. So 10 into 2, we write 20. This becomes log of 10 plus log of 2. Log of 10 we know is 1 to the base 10. Log of 2 to the base 10 is 0.3010. And therefore log of 20 is 1.3010. So this becomes x is equal to minus 37 into 1.3010. If we multiply this, thirteen into 37 will be 370 plus 90, 111, 48137. This will be 48137 negative. 3 digits to 48.137. And therefore we can say 10 raised to power minus 48.137 is equal to 1 by 20 raised to power 37. Now 10 raised to power minus 1 is 0.1. 10 raised to power minus 2 is 0.01. Anything in between will be of the form 0.0, 2, 3, 4, 5, 6 and so on. And therefore 10 raised to power minus 1 point something will have 1 0 after the decimal. So like the previous case, we look at the integer greater than least integer greater than equal to the power. Minus 48.137, the least integer without the sign is 48. And therefore there will be 48 zeros which will be before the number, or 48 zeros immediately after the decimal in the value of 1 by 20 raised to power 37, and that becomes my answer. Easy question, standard process, should take about 2 minutes to solve. You have to find the value of 6 plus log of the base is 3 by 2 and the expression is 1 by 3 root 2 into 4 minus 1 by 3 root 2 into 4 minus 1 by 3 root 2 up till infinity. So I'm dealing with this value first. If I write x is equal to 1 by 3 root 2 into 4 minus 1 by 3 root 2 into 4 minus 1 by 3 root 2 into 4 into root of 4 and so on. The first repetition is happening at this point, and therefore this can be written as x is equal to 1 by 3 root 2 into 4 minus x. Multiplying the 3 root or taking the square root, taking the square, we can write x square is equal to 1 by 18 into 4 minus x, or 18x square minus plus x minus 4 is equal to 0. 18 fours are 72. So 18x square plus 9x minus 8x minus 4 is equal to 0. 9x into 2x plus 1 minus 4 into 2x plus 1 is equal to 0. So 9x minus 4 into 2x plus 1 is equal to 0. X therefore will be 4 by 9 or minus 1 by 2. Clearly it cannot be minus 1 by 2. This value will be positive and therefore x is 4 by 9. So we get 6 plus log of 4 by 9 to the base 3 by 2. Now, if we look at 3 by 2 and raise it, or if you look at 4 by 9, 4 by 9 is 2 by 3 raised to power 2, 2 square 4, 2, 3 square 9, which is nothing but the inverse of it, 3 by 2 raised to power minus 2. If we write 3 by 2 raised to power minus 2 to make the minus as plus, we will invert the fraction 2 by 3 raised to power 2, which is 4 by 9. So this can be written as 6 plus log of 3 by 2 raised to power minus 2 to the base 3 by 2, which will be nothing but 6 minus 2 log of 3 by 2 to the base 3 by 2, which is 1. And therefore, my net answer simply becomes 6 minus 2, which is 4. Option D. Again, there are two different steps involved. First, solving an infinite expression and then working with the logs. So I'm saying moderate level of difficulty could take up to 2 to 2.5 minutes to solve. And therefore, if you look at the overall test, slightly more than moderate level of difficulty, 6 questions we're looking for 21 to 24 minutes attempt time. My 6 questions will be 2, 4, 5, 6, 8, 9. Which are these? I'm not counting this outrightly because the terms are a little lengthy to look at. This always doing just the value. This can also get tricky sometimes. 1 minus log 3 to the base 2. Definitely not the easier ones. This is a simple question. Similarly, here also, the question is not very difficult. This one also I would have attempted, though in the end, the options are a little confusing. This question I think is lengthy, and as it is, I found it difficult amongst the 10. This I would have done, and this I would have done. 8 and 9 are standard process questions, which we have done exact questions earlier as well. This question again, I would not say one of the easier ones. It is easy to get confused by values and the repetition that is happening, and therefore definitely not the easier one of the 6. So my easiest 6 would be 2, 4, 5, 6, 8, 9. This is something that I will always attempt and get my 6 questions correct for a 95% time.